All right, so problem one on your sample final, this is essentially what you'll need to do. Essentially, your professor is going to ask you to make some sort of sketch, possibly, and then evaluate a trig ratio um, or a trig function at some angle, right, based on your sketch. So there's a definition that you can use. The definition says, let theta be an angle that corresponds to some point x, y on the unit circle. It follows that sine of theta is always equal to the y coordinate. Cosine of theta is always equal to the x coordinate. Tangent is y over x, because if you remember from right triangle trig, tangent is the same thing as sine over cosine. So if sine is y, cosine is x, put it together, tangent is now y over x. Cosecant is 1 over y. Secant is 1 over x. So those are the reciprocals of sine and cosine respectively. And cotangent is now the reciprocal of tangent. That's x over y. So we use the unit circle shown to the right. So what you need is essentially the very first thing that you should do is like make a sketch of this unit circle on your exam. Before you even answer any of the problems, just draw that unit circle out. You can memorize it, right? If you draw it out so many times, you will probably have it memorized anyways. But at least memorize the angles that I have in purple, right? The purple angles are the multiples of 90 degrees. Those are where the angles intersect the x or y axis, and they have specific coordinates, right? Okay. Also, you would like to find coterminal angles if needed, because sometimes you're not going to get an angle measurement between 0 to 2 pi. What they can do is throw an angle that's a little bit greater than 2 pi, or they throw an angle a little bit less than 2 pi. Not less than 2 pi, but actually throw an angle that's a negative measurement, right? Which rotates clockwise rather than counterclockwise. Okay. So for problem one, it says compute the exact value for each. If a value is undefined, then you write undefined. So whenever we'll have a value that's undefined, that will be because the ratio will have a division of 0. Okay. And then show your work to justify your answers. So what I would recommend that you do for each parts A through E, is you make a graph, make a little sketch. Doesn't have to be the most articulate sketch, but at least a little sketch of understanding. After you apply your sketch, you label some sort of points, coordinates, or whatever, and then use the formula that I mentioned previously. All right. So for example, in part A, it says you want to find cosine of 0. If I want to sketch that angle, an angle of basically 0 degrees or 0 pi, that's where your x and not that's basically where the two sides, the two rays of your angle, they just basically are on the positive x-axis, right? So here is the vertex. The vertex is always the origin or the center point. And now what you have is that both the initial and terminal side is this x-axis. Okay, so this would represent basically 0 pi. Now from the unit circle, 0 pi, right? If I just draw some random circle here just to show you, the coordinates for this point is going to be 1 comma 0. So by the definition, cosine of 0 is always equal to x. So you're going to get 1. I think that's more than enough work to show. Now, notice my circle is not art, like, it was done by scale, but at least it gave me a little overview. Okay. Let's try it again for part B. In part B, we have sine of negative pi, right? So when you have a negative angle, instead of rotating counterclockwise, you rotate clockwise, okay? So the initial side begins on the positive x-axis. That's always the case. The terminal side now is, if we rotate clockwise, will be this way. And what we have is this, right? So here at this point would be where you have pi or negative pi, negative pi. which is, by the way, coterminal to pi, right? So you can make a note. You can say negative pi is coterminal to pi. So basically they share the same terminal side, that side that I showed in red. And the coordinates here are now -1, 0. So if you want to find sine of negative pi, that's the same thing as finding sine of pi. Okay? Sine, that's right. Sine of negative pi is equal to now sine of pi, because the fact that they're negative pi and pi are coterminal, by the definition, is always equal to the y coordinate. So that will give you 0. Okay, we could try again. Let's look at part C. Part C asks us to do secant of pi over 2. Now, in terms of degrees, what is pi over 2? It's a 90 degree, right? So again, here's my vertex. Initial side I'm doing here in blue. Oh, sorry. Now the terminal side is going to form basically a right angle for us. So this angle essentially is going to intersect with a unit circle. When it intersects with a unit circle at let's say pi over 2, the coordinates here are now 0, 1. So what is the definition now for secant? Well, the definition, if I want to evaluate secant of pi over 2, I have to do 1 over what? You do 1 over cosine. And cosine is always defined as x. So this is going to be 1 over x. What is my x value here? 0. 1 over 0 will give us undefined. So in this problem, we have a solution where it's undefined because you can't divide by 0. All right, so far we got 1, 0 undefined. Let's try again with part D. So I need to scroll up just so that way I could use an extra slide here. In part D, we want to do tangent of pi. So on the graph, we sketch pi again. So here's the vertex, here's the initial side. The terminal side will be now on the negative x-axis. So here is pi. Now, the order pair that's associated to pi was the -1, 0. So if I do the formula for tangent, it's y over x. Y is 0, x is -1. 0 over -1 is now what? 0. So you get 0 as a solution. Okay, and let's do part E. So in part E, we have, I think it was, I'll just look at it, cosecant. We have cosecant of 7 pi. This one is interesting now, because when I'm going to draw a graph, a rough sketch of 7 pi here, for the 7 pi, it's going to have to go make some overlaps, right? So let's see. Here's the initial side. Here's my terminal side. No, sorry. That's my vertex and that's my terminal side. So if I made one rotation, that's 2 pi, right? If I make a second rotation, this is now 4 pi. If I make a third rotation, that is 6 pi. So 7 pi is going to be on the negative x-axis, right? So what we see here, okay, is in green. In green, I have my 7 pi, right? But what you should make a note of is that 7 pi is coterminal to pi, right? So what we have here is 7 pi coterminal to pi. So therefore, cosecant of 7 pi, well, by the formula, by the definition of coterminal, is equivalent to computing cosecant of pi. And yes. Wait, hold on. Cosecant of 7 pi is coterminal to pi. No, yeah, 7 pi is coterminal to pi. So cosecant of 7 pi is equivalent to cosecant of pi. The formula for cosecant is 1 over y, because cosecant is the reciprocal of sine, like you were trying to mention. But you were saying the formula incorrectly. It's not y over 1 or sine over 1. It's 1 over y. Now, what is the y coordinate here? Well, for this point, we know it's -1, 0. So you get 1 over 0, which is undefined. And I think this is enough work to justify your solutions for problem number 1. Make a sketch and apply the unit circle definition.